Okay, so hey everyone, please let your friends know that the session is started, right? So थोड़ी देर में हम शुरू करेंगे and today we'll be discussing some amazing problems that will definitely help you out, right? So make sure that you invite them, right? So we will be starting in a minute, right? So जल्दी जल्दी से invite कर दो यार, ठीक है? So I'll be requesting again that please let your friends know that the session is started, right? So please join, right? And we'll be starting in a minute. Okay, so hey everyone, welcome to Geeks for Geeks. So as you have seen in the thumbnail, my name is Chirag Vaishnav, and I will be conducting the today's session. So in today's session, I have like planned a lot of things, right? So what we will be doing today is we will be solving uh, three questions, right? So what we will be doing is we will be solving three questions, and before that, as you have seen in the video, as well as you might have heard about it, the GFG is conducting a coding contest, right? So it's really, really, really beneficial. You will find all the links in the description. So we will be talking about that in between the session, that how it can be helpful for you and how you guys can take full out of it, right? Take full out of it. So we will be discussing about it in detail. So do watch till end. This is my sole thing that I want to tell you. Right now, moving towards the session, that what we will be doing today. Right. So what we will be doing today is we will be solving questions based on tree data structure. Right. So whenever it comes to company interviews, right. So 2 to 3 topics are there which are okay. I have to do this. Right. So it's like DP, trees and grass, right? So these are the few topics. Okay, these are the must one. I have to do this. I have to like definitely do this because some kind of variations or some kind of thing will be asked me related to these data structures, these algorithms in the topic. So today we will be doing that, right? So what I have done for the today's session, I have prepared two questions. Right. The one question is first. Let me just tell you that what I have planned for this whole 1 hour session, 1 hour 40 to 50 minute session, and we will be doing a lot of things. Just uh, just trust my word. We will be learning a lot out of this. Right. If you have already, I will be telling the questions, and if you know them already, then also the session will be helpful for you because it will help you to revise them. Right. So the first question that we will be doing is it will be mirror tree problem, right? So it will be the mirror tree problem, and with the help of this what we will be doing is we will be getting up or revising up, or if we are the new, we will be revising up. If we are not new, if we have experience in trees, we will be revising up, and if we are new, we will be building up from scratch, right? So I will try to be moderate on that level, right? And so what we will be doing, we will be first solving mirror tree. That is a easy problem as per Geeks for Geeks website, right? after that after that, what we will be doing is, after that we'll be solving top view of binary tree, right? And that's these are the two questions, and I have selected these questions because the combination of these questions will help you learn a lot of things, because there is not so much variation in the tree, as we know, because there are some traversals in order, pre-order, post-order, or line, vertical, right? These are the some things that we can learn from this. And if you are able to do a basic level of what I will say, traversals or basic level of things that are being used in the three question are clear to you, then you will be good to go. Believe me, right? So we will be discussing. So first we will be discussing top view, and then we will be discussing mirror tree, right? So let's get started with the session. But before that, I like to know that okay, you are active, right? So just write something in the chat box that okay, I am audible or visible clearly. Okay, cool, good to go, right? So let's start the session. So I will be presenting my screen. Okay, so I hope my screen is visible. Okay, cool. Okay. So this is the first question that we will be dealing with, right? So mirror tree. So first, let me explain you the question that okay, what basically the mirror tree states, right? So the question is simply given that you are given in a binary tree and you have to convert it into the mirror of it, right? So what basically a mirror is? Mirror is just whenever you stand in front of a mirror, your left hand appears at the right and right hand appears at the left, right? So this is the basic thing that we will be going into while discussing this question. So mirror tree, you can see this question, right? So basically what it is being given is that you are given a binary tree and you have to convert it into the mirror tree of itself, right? So what mirror tree basically is, I have tried to explain you in words that okay, the left will be right and the right will be left, but obviously that's not enough. So we will be moving into the presentation part, right? So let me just copy this image and paste it down here, right? And okay, so here we are. So what basically it is that we are given this tree, and what you have to do, you have to make this, and this is the mirror image of this tree. And how this is the mirror image, right? So we are given with the one, right? So this is the root node. Now the left to the root node, this is the left to the root node, and this is the right to the root node. And here it is the left to the root node, and it is the right to the root node. So is the left. So let's say this is my initial tree. So isn't the initial left has become the mirror right, and the initial right has become the mirror left, right? So these are the two things that okay, the one that I was having a here at left has become here at right, and one here I was having it right has become here at left, right? So what has happened is the left and right childs have swapped, right? Okay, so this is the question. Okay, but you told me for the one step. Let's go a bit deep down, right? So okay, so we have traversed this. So at this level, I am having my things done, right? So now let's talk about this. So here I'm having left, here I'm having right, here I'm having left, here I'm having right. So isn't this the same as what we are having is that for the two, the left one is 5, and for the initial two, the left one is 5, and for the mirror two, the left one is 4. And similarly, for the initial two, the right one is 4, and the mirror two, the right one is 5. So have they got swapped? Have they got swapped? Please let me know in the comment section that if you are with me or not. Okay, so Kushal says it's swapped, right? So I hope you got this still point, got this still point, right? So okay, so let's. So what we have done till now, we have understood the problem, right? So what you have to do, you are given a tree, you are given this tree, you are given an initial tree, and what you have to do, you have to convert it into a mirror tree. And for converting it to mirror tree, what are the conditions? The conditions are basically that what you have to do, you have to convert the left into the right and right into the left. So basically what you have to do, you have to swap them, right? Now the thing again comes that how we have to swap them, right? Because this is a basic human observation. Okay, we have observed that, okay, whenever we stand in front of a mirror, what happens? Our left appears at right, right appears at left, and the same thing or same analogy is being used here as well. So how to apply this thing basically to our code, let's say, right? So what will be the thing that we will be thinking of? So first of all, whenever it comes to tree, one thing that should come to your mind is traversal. That what kind of traversal we will be using here? What kind of traversal we will be using here? So basically, there are three kinds of traversal: pre-order, post-order, and in-order. So what are these basically? So these are just with respect to the route. If you are visiting the route first, then it will be pre-order. If you are visiting the route later, it will be post-order. If you are visiting the route in between, left to right, so it will be in order. Now you have to see that what will be the traversal basically, right? How the traversal will be, we will be going on with the traversal thing, right? So suppose it was 1 2 3 5 4. So I'm having this tree 1 2 3 5 and 4. Let's say here it is, right? Suppose this is the tree, right? So what you have to do, one thing, I hope it is clearly understood that what you have to do, you have to swap. And what you have to swap, you have to swap left, and what you have to swap right, right? So basically what you have to do, you have to swap the left and the right. But how I will get to those, how I will traverse, what will be my approach? These are all the questions which come to my mind when I first attempted this question, right? So I got to learn a lot of things from this question, because what basically happens in the case of DSA is you build step by step, you grow step by step. It's not like that okay, there are some algorithms and you will be directly jumping into that. What you have to do, you have to build from slow steps. That first, okay, first I will do the basic traversals, then I will do some variations with the traversals, then I will be moving more further, I will be trying to approach more difficult questions, right? So in this way it basically goes, right? So what we will be doing is, first we will be visiting this node, right? After that, what we will see, we will go to the left and we will go to the right, right? So for the left, what we will be doing is, what you have to do basically, you have to swap these things, right? But I will not be going deep dive into the traversal thing, that how it happens. If you want to know about the traversal, what you can do, you can go to the Geeks for Geeks website. A lot of videos as well as articles are there. You can take reference from that. So I will not be going deep dive into that. I will be basically discussing the approach what we will be doing here, right? And somehow I will cover the traversal part as well. So don't worry, right? So what will happen is, I will be traversing through all the things. So while traversing in trees, what happens is we do all the traversals recursively. Not all the travels, means the basic traversals that we go from left to right, we go recursively, right? And not talking about the queues, right? Not talking about the thing that we do with queue, right? So what we will be doing here is, first we are at one, right? Then we will check for the left subtree, and then we'll check for the right subtree, or we will check for the left node and the right node, right? So here at 3, I will be going at left, I will be going at right, right? So if at this point you are confused that what is happening, don't be. In 2 minutes, definitely in 2 minutes, you will be clear with all your doubts, right? So suppose I'm here at 5, right? So here it is null, here it is null, here also it is null, and here also it is null. And in the case of 3 also, what we are having is null and null, right? So suppose I came to 5 here. So 5 returned null, right? So if the node is null, if I even swap them, will that make a difference? Please let me know in the comment section. If I even swap them, will it even make a difference? Uh, Please let me know if you are able to do that. Okay, right, cool, right. So this will not make a difference. Okay, okay. So I will just make that quickly again, right? So two, three, 5 and 4, right? So it's a revision for us as well. So here we are. So first I went to left, then I went to right. So in this case we are having null here, 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 and we are having null here, right? So I went to here and I went to here, right? So as most of you have said, like Nandu, Vijay has said that okay, no, there will be no difference when we'll be swapping that null, right? So what you have to do, basically you have to swap the left and right. So we will be swapping left and right. So if I swap them, so there is no difference. So what I will be doing is I will be going back to here. And again, in the case of 4, the left of 4 does not exist and the right of 4 does not exist. It simply means that okay, they are null. So what I will do, I will do nothing and get back to 3, right? When I will get back to 3, when I will get back, when I will traverse back, right, what will happen is I will swap the left of the 3 and the right of the 3. What I will do, I will swap the left of the tree, 3 and right of the 3. So now what it will become is, so 1, 2, 3. I will swap them, right? I will swap them. So 4 will come here and 5 will come here, right? So I will swap them. So what you can see that the left of the 3 has become the right and the right of the 3 has become the left, right? Now I will be going here and I will be going here, right? So what we have done till now, we have checked for the right one. Now let's check for the left one, right? So again, in the case of left also, it was null only, right? So if we even swap them, it does not make a difference, right? So we'll go back to here. So it will return this. Now for the one, what we will do, the right is this, sorry, the left is this and the right is this. So what we will be doing is we will be swapping them again. What we will be doing is we will be swapping them again, right? So the last tree that will be forming, the last tree that will be forming for us will be 1, as we have swapped. So 3 will come here and we have only swapped the address of the 2 and 3 nodes. So won't the whole subtree for the tree 3 that is coming here will come here as well, because it all depends on address, right? 4, 5, and here it comes 2 again, right? So this will be the final mirror tree that we will be having, right? So what was our initial tree? So if this is the mirror, let's say, if this is the mirror, let's say, so can you feel the difference? Okay, the 1 is in the place of 1, the 3 is here, the 5 is here, the 4 is here, and the 2 is here, right? So what this simply states is okay, we have got the mirror tree for the tree that we were looking for, right? So I hope you got it right. So let me just again simply put down the things in summary. So if you're having any doubt, you can ask in the comment section. I'm looking at it right now. Okay. Okay. So basically this is the tree. So what we have done, we have traversed, right? We have traversed, and after the traversal, what we have done, we have swapped left and right, right? We did pre-order traversal, right? We did, right? So sorry, right? So what we did basically, we swapped left and right, and obviously we are having a base cases, and the base case is that root should not be null, right? So this is the basic logic that we have discussed to build on this question, and now we will be seeing that how the code is being written, right? So let's head over to the website. Okay, so here we are, the code I have written previously, right? So what basically it is, if the node equals null, right? If the node is null, then let, then it's okay. Let me just copy it. Okay, so it will not be formatted here. So let me just explain you there only, right? So what will happen basically is, if the node is null, then you have to return, right? This was the base condition, or this was the basic condition that we are looking for, that if the node is null, then you have to do nothing. After that, the main gameplay that we were playing is that first you have to check the whole left subtree, then you have to check the whole right subtree, and after that you have to swap, and after that you have to swap. So it will be post order traversal, right? So what we will be doing is, first we will be taking a node temp, right? After that we will be calling it for the left subtree, and after that we will be calling it for the right subtree, right? And if it's null, then we will be returning and backtracking to our case. After that, what we will be doing is, we will be swapping them. So this code is nothing but of swapping. So what we did basically, first we stored the value of node left in the temp variable. After that, we put the value of node right in the node left, and in the node right we put the value of node left that we have stored earlier, because now it is changed. It has having node right's value, right? So what we did basically, we traverse and we swap the values. So with the help of this code only, let me try to give you a glimpse of one more example, and then we'll be moving to the next code. Right. So here we are. So let's take a random example: 2, 3, 4, 5, and 6. Let's say, right. So according to our code, what was there is, if it's null, then we have to return. Else, else if it's null, then what you have to do, you have to return. Else if it is not null, then what you have to do, if it's not null, then what you have to do, you have to take a variable temp, right? And then call the left part of the tree, and then call the right part of the tree. After that, after you have traversed the left and right, means you are at the lowest level, and then what you will do, we will be building up on that level. So this is basically how recursion works. So this is hard to visualize at the first step, but yeah, when you will be doing a lot of questions like this, like you will be doing 10 to 15 questions like that, you will start getting some idea, okay, how to visualize this. And the best thing to best trick or best part that how you can visualize it is by writing the code. You have to write the base cases, you have to build upon the tree, and this is how you will get, right? After that, what you have to do, you have to do swap left and right, right? So this is the basic pseudo code that I have written here. So let's traverse. So one is not null, then we will be going to the left, right? After going to the left, we will check, okay, 2 is not null, then we will be going to the left, okay? Then okay, it's null, so what we will be doing, we will be returning, right? We will be returning. So it's we will be for the case of 2, what we are doing, you are having 3 here. In the case of 2, we are having 3 here, and here it is null. So what we will be doing, we will be swapping it. We will be swapping it. So our first swap will happen, and it will become null here, and it will become 3 here, right? So again it will return, and we will check for this. Now now what will happen is, okay, we have checked the whole left subtree. Now it's turn for the right, so we will be calling for the right, right? In the case of right, first we'll go to left, because you can see it's not null, then we'll be going to the left. So as we go to the left, okay, both of the things are null, and here also both of the things are null. So what we will be doing is we'll be returning to here, right? We'll be returning to here. So after that, we will be swapping left and right. So in this case, you have seen, okay, if it's null also, it does not matter because earlier it was like 2, 3 and null. Now it's this. So null is also swapped. So in the case of null and null, it does not matter. But in the case if one of it's null and other is not, then swap will matter, right? So this happened, and after that, the swap here will happen as well. So it will be 6 here, it will be 5 here, and after that, here the main boss for this we will be swap, because what you have done, you have traversed in the post order, and you have, like, you are definitely sure that below this level all the things are mirrored, so only in the case of this, you have to, what you have to do, you have to swap the left and the right. So it will be 4, 6 and 5, and here it will be 2 and 3, right? So this is how it will be. So we have discussed the first question that I wanted to discuss, right? So I hope you got it right, right? So if you're having any doubt, just ask in the comment section, and then we'll be moving to our next problem. Please let me know if you're having any doubt. I will for sure address it. Okay, I have seen Siddharth's comment now. So thank you, Siddharth, for your wishes. We can move. Okay, so Dashan said we can move. Right. So I hope you got the mirror tree right. So we have what we have done. We have moved a step up. We have moved a step up. Now it's time to move more. And how we will be moving more? We will be moving more by taking up one more good question. So this was the easy level question. So I'm just closing the tabs as we have discussed it. And now we will be doing top view of binary tree, right? So it itself is a really good question, what I will say, right? It itself is a really good question, and you will definitely learn a lot out of this question. So let's discuss that what question states, right? So first we will be discussing what question states, then we will be discussing the logic that how we have to build on it, and after that we will be discussing the code. That's it, right? So given below is a binary tree, and task is to print the top view of a binary tree, right? And the top view of a binary tree is the set of nodes visible when the tree is viewed from the top, right? So let let me just help you here in it, right? So let me just, I have written something for you. So it's 1, 2, it's 3 here, it's 4 here, it's 5 here, and it's 6 here, and it's 7 here, right? So it's very important for you to make the visual correct, right? So because the question is according to that only, right? So I'm not that good at drawing, but I'll try my best. Okay, so what I'm trying to make here is, I'm trying to make here eye, right? And it's looking from the, so I hope that it's looking a good eye, right? And okay, and it's looking from the top, and it's looking from the top. So what you have to do, you have to reverse the top view of binary tree. So what you have to do, you have to return the so what you have to do, you have to return the top view of the binary tree, right? So basically what will be the top view of this? So if I will like see from this side. And okay, so this is the basic view, right? So when we will be looking from the top, so after that one node, the five node will be like hidden after it, right? After the two node, the six node will be like hidden after it, right? So what you have to do basically, you have to return 4, 2, 1, 3, 7. So this is the top view. So what you have to do, for each binary tree, you will be provided with a binary tree, and you have to return the top view of that binary tree. So first, let me know if I'm able to explain you the question correctly. If you're having any doubt at this question, so I'll explain you that first, and after that we'll be moving on. Please let me know that if you are clear with the top view of the binary tree question. So please let me know. Okay. Okay. So thanks, Dashan. So let's move on. Right. So what you have to do, you have to make an algorithm so that you will make computer understand. Okay, this is the top view of the binary tree. So what approach comes to your mind first when you see this kind of question? Basically, what's the thing that's happening here, right? So what comes to my mind is, okay, let's try to think how we will be approaching a tree question. So I have discussed few things. That first, what you have to do, you have to look for traversal. You have to see for algorithm. Okay, Preetham, I can try it in Hindi, but the thing is that many of okay, there can be a case that many of the audience are not comfortable with Hindi, like from the south. So that's why I speak English so that everyone can be comfortable in that. So what I will do, I will try to do this session in English, and after that I will be asking my seniors that can I go with Hindi from the next session if it's good for you. Okay. So thank you, Preetham, for asking your query. Right. Okay. So I'm glad that you are here. So I will request you to see this session throughout. Right. I'm definitely sure that it will be helpful for you. And okay. And if there's anything that you're not able to understand, please let me know. I will try to make it understand you. Okay. So what basically it is, that what you have to do, you have to first find the traversal. Okay. What will be the traversal that I will be looking for? And after that, you have to think algorithm. Okay, I know the traversal, but for this traversal, what kind of algorithm we will be looking? Or you can first think of an algorithm. Okay, I will be using this, and for that, which traversal will be fit, right? So in my case, first I see the traversal, and after that I use the algorithm because it's kind of tweaky. You can tweak according to that. So both of the things will work, right? So what basically we will be doing is, for the case of traversal, let's say we are going with traversal first. Let's say we are going with traversal first. So once, yes, we will be using that only, right? So once it comes is recursion, and second is level order traversal. Level order traversal, that Shivam is saying that use horizontal distance, so we will be moving with that only, level order, right? So in this case, we will not be moving further with the recursion. Why? Because In the case of top view or the left view or the right view or the bottom view of the binary, these are the four variation of this view quotient that we are having basically. So level order traversal is very beneficial in this case, right? So what we will be doing is we will be doing level order traversal. In that also, we have heard of, or you might have heard of vertical order traversal. Okay, so the horizontal that Shivam was saying is was in the case KK, we are doing level order traversal. But in the case of level order traversal also, we have to check the vertical order. So what I mean by vertical order, I will be getting it to a point very soon, right? So it's also line traversal, right? So let me get you with the idea quickly, right? So what basically is we will be traversing level order, and with the level order traversing, what we will be doing is okay. So one level is that what we give horizontally, right? Okay, this is one, this is two, this is three, this is four, and this is five, and this is so this is the basic. You can say a small version of the tree that I have made here, like small version of the tree that I've made here. So this is the level 0, this is level 1, this is level 2, this is level 3. So this is basic level order. But now I have written vertical order. And why I have written vertical order? I have written vertical order because we will be moving with top approach only, right? We will be seeing it, okay, from the above how it's visible, right? So what we will be doing is we will be checking vertical levels. Okay, sorry. So one will be this, one will be this. Okay, I'm really bad at drawing. One will be this, one will be this, and one will be. So you might have seen that I have drawn some lines intentionally here. So these are due to my intentions. My intentions were not never not bad, right? Obviously. So 0 minus 1 minus 2 plus 1 plus 2. So what basically it is, what basically I'm trying to explain here, or what basically I'm trying to set it up here, right? So what basically I'm trying to do here is I'm trying to assign, okay, this is the vertical order that a node is having, right? So what I will be doing is I will be traversing the whole, and what I will be doing, I will be traversing from upwards, and we will be doing level order traversal. So it's not recursion. In the case of recursion, we go to the we go to the leaf nodes of the tree, and then we traverse back, and from the base we build our cases. But in the case of level order traversal, what happens is we build a case from the starting. We build a case from the starting. We traverse level by level. So in the case of level by level, what we will be doing is what you have to do. You have to go to the top. You have to go to the top view. So in the case of top view, what we will be doing is we will be assigning vertical levels to each, and for each vertical level, the first node that contains the first vertical order will be our top view. So in the case of 0, this 5 is also having 0, and this 1 is also having 0. But what is the 0 level that is beneficial for us? What is the 0 level that is beneficial for us? The first one. So at each level, for each level minus 1, minus 2, 0, plus 1, plus 2, we will be taking, okay, what is the first node that is coming in that, and we will be taking that only, right? What is the first node that is coming in that, and we will be taking that only, and we will be taking that only, right? So this is what you have to do. So let me just write it down again here. One, two, three, four, five, 6, and 7, right? So two things we will be using here, right? Because we have discussed the code, okay, what you have to do, you have to do vertical levels and all the things. But what you have to do, so let me just give it again once more as well. So what you have to do, you have to take two things. You have to take a map, and you have to take a queue, right? So in the case of map, what we will be doing is, in the case of map, what we will be doing is we will be taking, okay, we will be taking, okay, line is equals to node, or line comma node, let's say. Okay, that for this line we are having this node, for this line we are having this node. Why we use map? We use map because, okay, for okay, so why we basically used map, right? So we used map because, okay, for each line you only need one, for each night for each line you only need one, right? So for each line we will be having lines, and for each line what we will be doing, we will be taking one. Okay, I need the first one only, and in the queue what we will be storing, we will be storing node comma line, right? We will be storing node comma line. So how level order traversal works, it basically works like this. Suppose I'm having a queue here, so I put one here, then I extracted the one. Then I have put, okay, if left of one exists, yes, it exists. Two. If right of one exists, yes, yes, it exists. Three. Right. And then we will be checking two. Okay. So we will be popping two out. We will be checking if left of two exists. Yes, it does. If right of two exists, yes, it does. And then after it's complete, we will be checking three. So if left of 3 exists, no, it does not. If right of 3 exists, yes, it does. 7. So after that, we will be checking 4. So 4, we will popping out and we will checking. If left of 4 exists, no. If right of 4 exists, no. Then we will be moving further. We will check with 5. If left of 5 exists, yes, it exists. 6. Do right of 5 exist? No, it does not. So we will not. So in the case of 7 also we will check no. No, left and right does not exist. In the case of 6 also, left and right does not exist. So in this way we will be traversing our whole node. So in this way we will be able to traverse our whole node. Now, why we used level order traversal? We use level order traversal because we can assign them by a choice, right? So let's say I started with this. I initialized, okay, my node is 1 and the line is 0, and I pushed it here. My node is 1 and my line is 0, right? Then I traversed. Then I checked that if line 0, if line 0 is already present in my map or not. So in the first case, the line 0 was not present. So we stored 0 1. So in this we are storing line comma node. Why? Because line is our main key that we are searching for. Line is a main key. That's why line is on the first priority or in the left. After that, what we will be doing is we will be checking. Okay, we have checked, so we will pop it out and we'll check if left exists or not. 2 comma minus 1 and 3 comma plus 1. So you might be wondering that, okay, why it's minus 1 and plus 1. It's minus 1 and plus 1 because what we will be doing is, if we are moving to left, we will be doing minus 1, and if we are moving to right, we will be doing plus 1. So if we are moving to left, what we will be doing, we will be doing minus 1. If we are moving to right, what we will be doing, we will be doing plus 1. So 2 and minus 1 we have stored here, and 3 and plus 1 we have stored here, right? So now what we will be doing is, we will be popping it and we will be checking, okay, do left of this exist or not, right? Do left of this exist or not? Now if left of this exists, so what we will be doing is 4 comma minus 2. And if right of this exists, no, right does not exist. So what we will be doing is, we will be pushing it in 4 comma minus 2. So why minus 2? Because whenever we go to left, we will be adding minus 1, minus 1, minus 1, minus 1, right? So it will be like minus 1 here, it will be like minus 1 here. So this case is minus 1, this case is minus 2. It will be 0. Similarly, in the right, it will be plus 1, it will be plus 1. So it will be 1 and it will be 2. Similarly, it will be 0 and it will be minus 1, right? So this is how it is going to work. So let me just quickly go it back. So 4 comma 2 left and right. After that we'll be checking for 3 comma plus 1 because we are moving in the queue, so we'll be popping the first element only. So after that we'll be check, okay, do left exist? No, it does not. Do right exist? Yes. 7 comma plus 2. So why plus 2? Because plus 1, I've been explaining you that plus 1, right? So it will be, so what we will be doing is, we will be adding it to 7 comma plus 2, right? After that, for the case of okay, for the case of, okay, after 2, okay, the right exists, so it will be 5 comma 0. So minus 1 plus 1, it will be 0. And in the case of this, 6 comma minus 1. So I will not be explaining deep dive into it that why it's 0 and minus 1, because I have explained. So it's basically 0 minus 1, minus 1 minus 1 minus 2, minus 1 plus 1 0, and 0 minus 1 minus 1, right? So what we will be doing here is, okay, so we have traversed this and we have traversed it, so we will push, okay, for the minus 1 it's not existing, so I will push it here. In the case of plus 1 it's not existing, I will push here, right? After that, after that it will be 50, it will be 50 here, right? After that what we will be doing is we will be checking for 3 and minus 1, so 7 and plus 2, right? So this is the basic thing, so 7 and plus 2. After that what you have to do, you will be checking for 4 and minus 2. So 4 and minus 2, no, there are no left and right. Now we'll check, okay, for minus 2 isn't it, is it present in the map or not? So, okay, minus 2 is not present, so we'll be adding it to this, right? After that 5 comma 0. So for the case of 5 comma 0, we will be checking, okay, left exists, yes, left exists, 6 minus 1. Now is the case that you will be learning something, and the thing is that, okay, okay, we have used 5 comma 0. After that what we'll be doing is we'll be going with 7 plus 2. So in the case of 7 and plus 2, okay, left and right does not exist, so we'll be popping that out and we'll be checking, okay, 2 does not exist, so let's put it here, right? After that, after that, so okay, so in this case, at each case what we are doing, we are checking if the level is present or not. So 0 was not present, we added. Minus 1 was not present, we added. Plus 1 was not present, we added. Minus 2 was not present, we added. Was 0 present? Was 0 present? This was the question that I wanted you to ask in the comment section, but obviously you didn't, right? So okay, there are some questions in the comment section. I will answer them later this session in the ask me anything part, that will be after 10 minutes, right? So 0 was already present in the map. You can see 0 was already present in the map, so we didn't edit it. Why? Because we only need the first uh, resemblance of that particular thing. So the first resemblance was over, so we did not require that. So okay, so was 0 was already present, so we didn't edit it, right? After that 7 comma plus 2, now we will be going to 6 comma minus 1. So for 6 comma minus 1 also, it does not exist, left and right does not exist, so we will be having a queue empty and a case will be over. But before that we will check that for minus 1, for minus 1, is there any vertical order that is existing in the map? Says for minus 1 we are having 2, so minus 1 we are having 2. So here you can see for the minus 1, 2 is upper than 6, both are in the same, both are in the same vertical line, but 2 is above, right? So that's why we use the map, so that we will be getting the first iteration of the first resemblance of that particular leveled element, and with the help of that only we are able to accomplish our goal. And this was the basic logic behind top view of binary tree. So I hope I was able to explain you the basic things, right? So let's head over to the question part again. So here we are, so let's discuss the code, how it is going to work, right? So it will be as exactly as that we have discussed so far, right? So you can see that what we have done, first we have created a map, of int comma int. After that we have created a vector in which we will be storing our answers. Now in every tree question you must have a root node, right? In every question you must have a root node. So if root is not null, then you have to return a. If root is not null, then what you have to do, you have to return a, right? After that what you have to do, you have to put a queue and make a queue of node comma level, right? Int here is level, and you have to push, okay, the root node is at 0th level, right? After that we will be doing the level order traversal. In the case of level order traversal, what we will be doing is we will be taking out the information of the first element as we have to use it, and we will be popping it. After that we will be checking, okay, if that level exists in our map or not, if that level exists in a map or not. If that level exists, okay, there is no issue. And if that level does not exist, it means that equals 0. the count is 0, then what you have to do, you have to add it in that, right? After you edit it, what you have to do, you have to check for the left and you have to check for the right, and similarly push it in the queue if left or right exists, and you have to run this till your queue does not becomes empty. And at the end, what you have to do, you have to push, you have to like push all the elements that are present in your map, right? And that will be our answer, right? So I hope you got the solution right. So we have discussed this question in detail, and we are having 10 minutes spare for the session. So basically, the code iterated along this side only, right? So what we basically did, we created a map, we created a queue. In the queue, we first check, okay, if it's null or not, if the root is null or not. If the root is not null, then we move further, and if the root was null, we wouldn't have moved further, right? So if the root was not null, so then we moved. So what we did, we first basically put the root element with the level 0 in the queue, and then we traverse with -1 +1 according to the availability, if left exists or not, or right exists or not, right? And in the base cases, we will be backtracking. And as we were doing level order traversal, what we were doing at each instance, we were checking, okay, the level at which we are right now, is it present in the map or not? If it's present, then we have to do nothing. And if it's not present, then what you have to do, you have to get back to it, and you have to check for it once again, right? And the first iteration, or the first resemblance, or the first glimpse of the level that we are having is, that is a final answer, and then we will store it in a vector and return this, right? So this was the basic approach behind this question. So I hope you got the solution right. So now let's see. Now let's start the AMA question. So okay, so Konark is having some doubts. So can we? Okay, you got the solution. Okay, Michael asked, sir, do you guys like live doubt session in your CP course? Planning to register. Okay, uh, there is live session. You can book some live sessions, right? You can ask, okay, and I'm having this doubt, and we'll be solving that for you, Michael. Was actually going to ask if we need a map of int and vector pairs, but as question goes, we only want the first occurrence of an element in the vertical line order. Okay, so Konark, yes. Okay, so I think the answer is in your query, or the thing that you said is in that only. That okay, only we only need the first iteration. That's why we said, right. Obviously, we can use all the iterations and all the things, so all the elements, but it's of no use to us. So that's why we only use the first resemblance or first occurrence. So can we use DFS for this problem? So as far as I know, the problems like this will we will not be able to use DFS. Why? Because you have to use the top view of the approach, right? You have to make them level, and you might have observed in the approach that what we were doing with the help of root 0 -1 +1 +2 +3 +4 +5. So these questions are of the level order traversal. So some questions are made for some algorithm specifically, and we can use in that manner only, right? So I think this is one of the best way to do this question, right? And apart from that, if there is any way possible, so I will try to search it in, and I will try to get back to you somehow, right? So I will try to make a next session on it specifically. If there is another way that I found, okay, we can do this question from that way only. Also, I will try to make a session on that as well, right? So okay, I think Konak, your doubt is clear. So if you're having any other doubt, you can ask, guys. I'm available for the Q&A. So let me stop sharing my screen. Right. So please let me know if there are any doubts. We'll wait for a minute, and after that, we'll be signing off from the session. I had an amazing time with you guys. I hope you learned a lot, and thanks from staying from the start till the end. It's really hard, right? So if you're having any doubt, you can ask, or we can end the session. Okay, so as you're having no doubts, and we have discussed the both questions in detail, I hope you got to learn a lot of things out of it. So thank you guys for your time, and I hope I was able to help you out. So if you like this video, and if you like the whole part, so do like this video and subscribe to this channel. It will for sure give us a boost, right? We work so hard for you guys. Also, okay, it was an informative saying CFG. Okay, thank you, Konak, for your time, right? And also, GFG is conducting a lot of coding contests and all the things that will be helpful for you. So do register for that, right? So we are having a coding contest. So do register for that. Also, a lot of articles and videos are present on Geeks for Geeks website as well as in YouTube channel. So do check it out. And thanks for your time. And we'll see you in the next time.